So we're going to get an infrared spectrum on our recrystallized trans-cinnamaldehyde, or trans-cinnamic acid rather, which was in the desiccator. It should be nice and dry by now. So we can take that little beaker out. And I need to remove the filter paper so we can get a mass percent recovery. Tweezers. Reach in there and grab the edge of the filter paper. Just try to scrape any extra solid off of there. And then we'll grab one of these little micro spatulas, because that's going to be the best tool for working with it over in the IR station. Get rid of that filter paper. So the beaker with the recrystallized trans-cinnamic acid in it. Has a mass of 8.114 grams. 8.114 grams for the beaker with the recrystallized trans-cinnamic acid. Yeah, it's a little dirty. We need to grab a KBR kit from the stockroom. That for later. KBR kit number 3 here. And we'll take the KBR kit and our sample and our micro spatula. Over to the station. So popping open this kit, we've got our agate mortar and pestle. And we've got our 3 pieces of the pellet die. So we take the one with the smaller protrusion and stick the little cap on it. And then we want to take just a little bit, a couple of milligrams of our sample. Doesn't take much. And we're going to thoroughly grind that in the mortar and pestle and break it up. And it's pretty smeared all over it. Not really moving anymore. Oops. Dropping things. And then we need some KBR. So we get our little scoop. And this KBR had been drying for about 5 days in the oven, so it should be a lot drier than the KBR was when we did our trimethylene pellet. Let's fill that up completely. Drop that in there. And it's actually not a very humid day today, so Should be a good day for making a KBR pellet. So now we're going to grind those together. This KBR is a little coarser than some KBR that we've purchased in the past, so I am actually grinding the KBR a little bit more, as well as mixing it with the sample. Trying to make sure it comes off the sides of the mortar as well as the end of the pestle. And you really can't grind it too much. What you want is a uniform mixture. And so that seems pretty free-flowing in there. That looks pretty good. Now we're going to transfer KBR from the mortar into our little pellet die, somewhere between 1/3 and 1/2 of our mixture. Pick that up and kind of tap it down. We want it to be pretty well uniformly coating. Stick this piece in top. And then that needs to be transferred into one of our wrenches here. This one looks like it's come loose. So, you know, someone has tightened this one all the way down, so we no longer know where it should be set to. Yeah, but we'll figure that out. So now, as always, the biggest challenge is getting that into here without the pieces coming apart. And we want to press that down until it meets and let that sit for a little while to fuse the pellet. And as always, it's a little difficult unless you've got both thin and strong fingers to get that apart. So my usual technique is to cover that so it can't fall out, and then just gently bang that. And pull out the long one first, and then the short one. And what you'd like is a pellet that you can kind of see through, at least see some of the light through. Right? So we've got a decent pellet. Not transparent, but I don't think the KBR is very good quality. So we're going to take that over to the IR instrument. I'll set this down while I'm logging in. Nothing in our chamber. So we'll open up the software, Omnic. And I'm going to check the experiment setup. It says IS5 standard here. That's probably the right one. 4 scans, resolution of 4 reciprocal centimeters, and we're going to show it in percent transmittance. This is the default experiment. That's the right one. Now I'm going to OK that and collect background. Asks me to please prepare the collect the background spectrum, which means make sure there's nothing in the chamber, which I already did. And you can see it's updating 4 scans. Here's our background. It says single beam. We've got our water vapor, our CO2 in the middle, and then our water vapor there, a little bit of hydrocarbon. That's a good background. I can close that. I don't need to save it. because it's saved in the memory. And now I'm going to hit the collect sample, and this is where you will enter the lot number that you assigned to this material, and I'm going to enter trans-cinnamic acid. And this is the recrystallized sample, which I'll add later. So please prepare to collect the sample spectrum. That means put the sample actually in the beam. So we're inserting it on that little V so we can see through the V to our sample. Putting that in there. Make sure it's tight. And then I'll OK that. And it will collect its 4 scans and tell me my background age is 0 minutes old, because I just ran it. So there we have a spectrum. You can see that, as usual, the baseline is sloped because there's more light scattering, especially with a slightly opaque pellet out here in the higher energy range than there is in the lower energy range. But it's looking pretty good. There's definitely a carboxylic acid in there. Looks like a carbon-oxygen double bond stretch or two. Some other peaks. So we can save this. Save as. And I'm going to want to go to the data folder and my folder, 2020 Fall Lab, and I've got one called Extraction Lab. That's a logical place to put it. I'm going to set the file name to the title, so it's called trans-cinnamic acid, and that's the raw data. I'm going to take the sample out while I still remember it's there. So now, since the computer lab's not working anyway, we're going to have to do all the processing here. Might as well do it now. I'm going to go to baseline correct, and I'm going to put my little gray line on the region that I know is baseline to correct for that overall slope. And I can drag those boxes if I miss a little bit to make sure they're in the right place. Here it doesn't actually return to baseline, so I wouldn't want to make those baseline. This one's probably not actually baseline either, but that is. And then I'm going to take that box at the far end and drag that up. So I've got a better, flatter baseline now, and I'm going to replace that. And then I'm going to use the T here, the annotation tool, to drag that label, the trans-cinnamic acid label, out of the way. And I'm also going to double click on it and say comments recrystallized. From four to 1 aqueous ethanol. Maybe even put that on a separate line. The little asterisk in front of the label there tells me that I have done something to the raw data. I've corrected the baseline in this case. I don't really want to see that chatter either. So what I can do is use the region tool here to hover over that whole region. I know that's water vapor because KBR is still a little wet even though it was in the oven. And I can actually straight line it. I can just make a straight line there. And then go back to my select tool so I don't have to see the chatter, which will make it easier to avoid having the label obscured. So that's pretty good. And I want to label some peaks here. But before I do that, I'm going to change my display limit. And instead of starting at 65, I'm going to start at 60. So there's a little room between the peaks and the base. And then I'm going to go to Find Peaks. And set my threshold down somewhere so that I can see all the significant peaks. And I can replace that as well. And then using the annotation tool, if I want to, I can move those peak labels over here. It doesn't really matter. And I could actually label this one if I want to by pointing at it. But somewhere in these crowded regions, you know, it's sometimes worth moving the peak labels so you can see them more clearly. This one at 1493 is probably not significant. It's not that large. I'm going to move some of these peaks around so I can see them clearly. So a lot of peaks here. Some of these are small. These two are definitely too small to be worried about. I'm just going to delete those two. So we know that trans-cinnamic acid is a monosubstituted benzene, and we actually have some peaks down here at 767 and 706. Those are in the region that you would expect to see a pair of peaks for a monosubstituted benzene. The carboxylic acid is obscuring the sawtooth pattern that we often see in here for monosubstituted benzene, but these peaks down in that 700 region are usually pretty diagnostic. I also should see peaks at around 1500 and 1600 for the ring breathing of the benzene. And I got one at 1493, that's pretty close to 1500, 1578, that's probably the ring breathing. These peaks here, the 1685, that's probably my carbon-oxygen double bond, and the 1630 would be my carbon-carbon double bond. 1685 is because the carbon-oxygen and carbon-carbon double bond are what we call conjugated with each other. It shows up at 1685 instead of at about 1720, which is where you would normally expect to see an carboxylic acid. And then 1450, right, 1421. A lot of these peaks in here, these are probably fingerprint region, carbon-carbon single bond stretching, carbon-oxygen single bond stretch. We would expect to see an aldehyde peak at about 28 something for the carbon-hydrogen stretch of the aldehyde, or never mind, sorry. For the carbon-oxygen stretch of the cinnamic acid, we'd expect to see it, the single bond stretch somewhere in this region here. Probably that 1225 peak, or maybe this 1287 peak. Hard to say. So I'm going to save that. In my folder, under 2020 Fall Lab Extraction Lab, and this is going to be trans-cinnamic acid